In this lesson, we'll be doing an activity based on trigonometric ratios, finding the side as well as finding an angle. So let's start with finding a side. Suppose you are given a triangle, and the triangle has the opposite side being, let's say, 4, and this side being, okay, let's say here we've got 5, and here we've got the angle. What will the angle be? Suppose the angle here is theta, and they say to you, first of all, let's find the angle theta. Well, we know to find angle theta, what are the two sides which we have? We have the side that is opposite to the theta, which is the angle. So we have the opposite, and then we have got the hypotenuse. So what is O over H? Remember, we've got the mnemonic SOHCAHTOA. So that's what you must ask yourself all the time. We've got SOHCAHTOA. This means that we have got opposite over hypotenuse. This means we're going to use the trigonometric ratio sine. So you can say that sine theta is equal to the opposite over the hypotenuse, and then sine theta is equal to the opposite, which is 4, over hypotenuse, which is 5. And then to find theta, we're going to look for the arc sine. This means we're going to say that theta is equal to, when sine goes that side, it becomes the arc sine, or sine to the power of -1. And then it's 4 over 5. And let's see what our theta is there. So we're going to calculate the arc sine of 4 over 5, and the answer is 53,13. The answer theta is equal to 53,13 degrees. So this is 53,13. 53,13. And now let's find the side that will be here. Let's say it's x. Now let's solve for x. How will we solve for x? Let's erase here. So remember, this is just a recap. It's not part of grade 12 content, but it's part of grade 10 content actually. So this is just a recap to introduce you to trigonometry without fearing it. So now we can use the angle that is given and one of the sides here to find x. I want you to be able to use trigonometric ratios before you use Pythagoras theorem. Make sure you are able to use trigonometric ratios. So in this lesson, don't use theorem of Pythagoras. No, just use angles. So we are given theta and the opposite, and we are given theta and the hypotenuse. So what can we use here? We can use, because we are looking for x, we are looking for the adjacent, and we are given the angle. We are given the opposite, and we are given the hypotenuse. So we can use one of the two. We can use cosine or we can use tangent. I hope you can see. So yeah, we can use cosine and we can use tangent. So we can say that cos of theta is equal to adjacent, which is x, over 5. So cos theta, that is cos of 53,13, and that is equal to x over 5. And to get x on its own, we're going to cross multiply, and then you multiply x by 1. Then x is equal to 5 cosine of 53,13. And let's see, our answer is 3,00. So here we get 3,00 meters. So we can use cosine, you see. So let's see if one wanted to use tangent. It must give us the same answer. We're going to say that tan theta is equal to opposite. This time it's opposite over adjacent, and then it's the tangent of 53,13, and that is equal to the opposite, which is 4, over adjacent, which is x. And here we actually have x tan 53,13 is equal to 4, because you cross multiply. And we're going to divide both sides by tan 53,13, leaving x on its own. Let's see what we get there. We're going to say it's 4 divided by the tan of 53,13, and our answer here is also 3,00, and we get 3,00 meter. So as long as you use the correct trigonometric ratio and the angle, you will always get the same answer. So remember, SOCATOR. Or this one interesting one, oh hell, another hour of algebra. So make sure you're able to use it as well. Thank you for watching.